Bro.
All right, so really quickly, here's the rest of the week into Monday. Monday will be your next quiz. I feel like maybe I'm wrong, feel like we didn't exactly crush that bid on yesterday. That's the way I feel based on the reactions that I got. Maybe I'm wrong. Maybe I'm wrong. Again, I'm talking about like on average, individuals. Like, didn't see a lot of super happy looking faces as people turned it in. I haven't looked at it at all. So what again, I'm gonna try to give you at least one exit ticket every week. Try to give you at least one exit ticket every week. You have a short week this week, but I still see you on Thursday for you guys. It's only difference is it's a short class instead of a lot of class. So I help you miss the exit tickets. Remember, exit tickets are not something you can make up if you miss it. There's no retakes. I don't remember to change that. Oh, you have. Or lunch or whatever. Okay. So on Thursday, we will, even though it's a skinny day, we'll fit a quick exit ticket in. It'll probably be based on it's gonna be on circles for Denver. It'll probably be like the first example that we did. Phone should not be out. Phone should not be out. Now let's go ahead and use the ball. On one there. No, we're not gonna have a lot of grades this quarter. So I kind of talked about this, but if anybody was absent, first of all, you start getting pulled out for testing really early. I want to say you might even start getting pulled out. I'm almost positive you start getting pulled out in April. So the ELA or language arts, I believe, is the first for most of you, and that's a big one. I don't know if it's a 2-day thing for everybody, or if it's just some of you get pulled out one day and then some of you get pulled out another day, but it's one where I definitely won't see sure it's in the second period. It's probably a 2-hour, like it's the one you have to pass to graduate, put it that way. If you're in 10th grade. You have to pass your algebra equivalence EOC, which means you can take other tests and pass it. You have to pass that. That's your math one. And then you have to pass your 10th grade reading writing. If you don't pass those, you do not graduate. I don't care what your GPA is, how many credits you have, you cannot graduate. So that's a big one. And a lot of you are in 10th grade, so a lot of you will be put out for that. Let's see, and then depending on whether you're in like AP classes, some of you get pulled out, some of you are in probably biology, they have an EOC. So anyway, there will not be as many grades this quarter because we lose like a month at a time. And then, our EOC is in the middle of May, so we're done in the middle of May instead of going all the year. So because of that, you also won't have as many exit tickets. The exit tickets saved a lot of you. I'm going to give the same number of exit tickets, but you won't be here as much. And if you miss it, you don't get to make those up. So make sure you are here and present in this class. Don't oversleep on days when there are exit tickets because you're already going to miss some because of the test. Like I said, that's what saved some of you at the end of the quarter or throughout the quarter. Our recording. Oh, it's frozen. I was gonna say, why isn't it lit up? Let me just make. I'm almost positive I hit record. Yeah. All right. All right. So circles. I feel like I'm pretty good about telling you when something is going to be, and you may not agree that it's easy, but it's certainly easier than some things when I say that. Circles is not one of those things. Circles is hard. It is going to be, for a lot of you, probably one of the top 3 most difficult things we've done. Mainly just because there's a lot. There's just a lot of stuff. So with that in mind, take advantage of the first quiz because that's by far the easiest circles quiz. What's the blue line? This is just old review. What's the blue line? Rihanna. Diameter, good. So a line, the book has definitions. Actually, I don't even know if they define some of these things. They just expect you to know probably something. But the diameter is a line that goes from one point on the circle across to the other side of the circle. The key is it goes through the center of the circle. So that point right there, where you have those 2 lines sort of meeting, that would be the center of the circle. So what's the red line? So the radius is from the center of the circle out to any point on the circle. It's the same length no matter where you go. If I start in the center and I go to any, drawing a straight line. If I go from the center to any point on the circle, that's the radius. That's actually how you create a circle. Does anybody remember the old school like compass thing that had a really sharp point and you put a pencil in it and you drew a circle?
They have that in this picture.
Yeah, I have it. I have something. We don't really use them, but that's basically setting a radius, like you move it back and forth to set the distance, and then you're creating points that are the same distance around the center point. So all of those points you're creating, so the line you're creating, is just a bunch of points that are the same distance away from the center, meaning they all have the same radius. Every point would have the same radius, therefore creating a circle. There used to be this thing, I used to show it in class. Have you ever seen those big, gigantic, like geometric things made out in big fields? Like, you ever seen something like that? They used to actually make the news. They said, "Oh, aliens created it. There's no way man could do that. It's impossible." Like I think there was. Well, I know there was an old movie I saw. Signs, yeah, that's exactly what it is. And there was an actual real news story. Whether or not they were just trying to get publicity, I don't know, but where people thought aliens made it. It's just literally they put a stake in the ground. They take a tractor and they tie a rope to the stake in the back of the tractor, get the rope tight, and then they just draw circle basically around that stake. They just keep going keep the rope tight, and then they keep drawing it, makes a circle, and then they clear out the field inside of that circle. So it's just geometry. Let's see. Oh, circles are named by the point that is the center point. So that would be circle M. There are a few ways you'll see it, but the most common is it'll have a little circle like that, and then it'll have an M. That means circle M. They might just say circle M. They might say circle M. But if you see that symbol, kind of like we have a triangle for naming a triangle, we have like a little 4-sided rectangle or parallelogram for naming those shapes. What else do we have? Those are the main ones that we have symbols for. So a circle will have a symbol, and then the middle point is the name of it. We can have line segments that go out. So if that was N, that would be line segment MN. The red would be line segment MN. So some of the same old stuff that we did when we did line segments will be in there. We will bring right angles and triangles in a lot. So again, A squared, B squared, C squared could be an option. It will be. You'll definitely do problems that don't have that in it. So there will be some stuff that you're familiar with. There's going to be a lot of stuff you're not familiar with. If you look at well, you don't have books. I'll show you. We'll come back to this. There's a lot of things that you've never seen before. So we'll go over some of these that you should know. These are throughout the chapter, so you'll see them as we do different chapters, but there are a lot of words. Chord, arc, central angle, circumscribe, tangent. I mean, this is one of the things that makes it challenging. It's just a lot of brand new stuff that you may have never, ever seen. Like I said, take advantage of the first quiz, because it gets much more difficult after that. Some of that stuff will be new, but some of it won't be as new. It'll be, diameter distance. All right, so with that in mind, let's look at the second one. What is shown in the two pictures below? So again, this is the OC. This won't be on the quiz. Any idea? I might call on for that. Shandy, you don't even really be with us probably. Any idea what I'm showing in the picture? Anything. So symmetry is actually not a bad. So if we have some symmetry going on, we learned about a couple of concepts. What can you tell me? Let's talk about the one on the right. The one on the right is the one where you really should know some things that are true about that. What can you tell me about the one on the right? What's it look like? How? What's it look like? It does look like a triangle, right? What kind of triangle? It is isosceles. So if we have, so again, this is not really what the topic is, but if we have an isosceles triangle, what do we know about an isosceles triangle? Isaiah, what's the answer to that one? What do we know about an isosceles triangle? So this kind of looks like a triangle with a line through it. It's not actually what it is, but it kind of looks like that. What's true about that isosceles triangle? So how do you know they're right triangles? How do you know it's right triangle? How do the congruence marks tell you that? That is sort of a concept that I'm talking about. So that's actually what the topic is. Do you remember what it's called? What is the line down the middle called? Perpendicular bisecting. So that's actually the topic. One thing I was just going to say before we got to that, if it is an isosceles triangle, don't forget, we also know those angles are congruent. So that's different topic, but again, they could somehow use that even if they can cross topics together on NEOC, and that way they cover two topics in one question. So I wouldn't be surprised if they did stuff like that on NEOCs. So what Isaiah said is absolutely correct. The topic here is that if we have a line that is a vertical line, what's true about this point right here? What's true about the point, though, the red point that I clicked? It is a midpoint. Remember, there's another review. We just did that last month. Midpoint would separate a line segment into two equal smaller line segments. So that is a midpoint. So that means this point right here is the same distance from both endpoints, right? That's what it also means. If this is the same length and that's the same length, then this point is the same distance from, we'll call that A and B. So that red dot, a little bit bigger, that red dot is the same distance from A as it is from B. But so is this point up here. This point up here, again, we have congruence marks up there. That point is the same distance from A as it is from B. The only way that can happen is if this line is straight up and down, if it's perpendicular to the line going left and right. If it wasn't, like imagine this line twists a little left or twists a little right, these might still be equal down here, but there's no way these would be equal. If I twisted it this way, then this one would be shorter than that one. If I twist it that way, this would be shorter than that one. It has to be perpendicular for all of those congruence marks to be there. So that's a perpendicular bisector. That's how you would identify that. If they tell you you have a perpendicular bisector, then it goes the other way. You know these two are equal and these two are equal, and any point I put. If I put a point down here, then those two lines would be congruent to each other. Any point on a perpendicular bisector is the same distance from the two. So that was the lesson on that one on the right. It's kind of similar over here. What is true about, so Shandy said it's kind of like got symmetry. What would that mean about this line right here? It is a bisector. They're both bisectors. That's why I say they're similar. The only way the distance can be the same from here to here and here to here and here to here and there is that line's got to be right in the middle. If it's not right in the middle, then those lines coming out. Oh, and then these would have to be at right angles also. That's how you measure distance. So those would be right angles that could come into play. You got a bunch of right triangles. So again, a squared b squared c squared. You got right triangles here. So potentially you could do a squared b squared c squared. If I told you to prove that these two triangles are congruent, how would you do that? How would you prove those two triangles are congruent? You do it with like without even adding anything in, really. How would you prove it? So these are congruent here, right? So there's one congruent side. Well, not necessarily. If it's a right triangle, yes. But how do we know that line is congruent to itself? Well, that's only true in a right triangle. If it wasn't a right triangle, we wouldn't be able to say it. Just because two sides are congruent doesn't always mean the third side. Unless it's a right triangle. We can change the angle measure to make different triangles. Yeah, it's the same side, right? That is a shared side. It's got to be the same length as itself, right? It's the right side of one triangle, it's the left side of the other. Well, it's got to be the same length as itself. It's the same exact side. So you could do side, side, side. You could actually, since we just said we know it's a perpendicular bisector, you could also have used the fact that it's a right angle somehow and what would we have done? Side, we wouldn't really need side angle side. Because then once we prove the other side, we'd already have side, side, side. So again, just something to think about. I don't know that they'll make you do proofs a lot on the EOC. I don't think there was a lot of proofs on the midterm, but you might need those concepts to then be able to solve something. All right, so that's all the review we'll do. Moving into circles, we'll be going over those throughout the different lessons. So turn to 189. Well, don't turn to it, but 189. So do some definitions first. We have Bristol films. Green. Yeah, that'll work. All right. So they do have radius and diameter in there, so they do have that. You should kind of already know those. So here is your here's your first one. You're probably not super familiar with, maybe not familiar at all. Chord. So kind of highlight that one. That's I would guess a new one for all of you. Chord. That's pretty simple. It just means you have a line segment and the endpoints of the line segment are on the circle. So what is a chord from that circle that they're showing you? Lissa, what's a chord for that circle? You can look in your book and look up here. What's a name a chord? That circle. Yeah, AB. The endpoint, it's a line segment, right? Line segment, and the endpoints are on the circle. That's a definition of a chord. Chance. Is there another one? Yeah. EB. Yeah, D. What is also true about EB? It is the diameter. It goes through the center of the circle, and it's a chord. The endpoints from the circle has sides. The endpoints are on the circle. So that is the diameter. It is also a chord. Is CF a chord, Chloe? The line segment. But what's true about a chord? What has to be true? Yeah, only one of the endpoints is on the chord, so a radius is not a chord. Diameter is a chord because its endpoints are on the circle. Radius, not a chord. I think that's everything. So what can you, before we go, I mean, you probably already looked, but what's true about the radius versus the diameter? Okay, remember that. You should know that. What's true about the radius versus the diameter? The radius is 1/2 the diameter. Or you could say the diameter is twice the radius. So that is definitely something you'll need to know. Sometimes actually most formulas deal with the radius, like they have the radius in the formula, but they'll give you the diameter in the picture. You have to remember, oh, I need to divide that diameter in half and get the radius. That's a very common, it's not really a trick, they're just testing to make sure you understand the concept. So make sure you put a big note around that. Make sure you use the appropriate line segment, the diameter or the radius, depending on what formula you're using. And there will be some oh, I don't know if you get any circle formulas on them. I think you do. I mean, you have the circumference and the area on here, but that's really all they give you, which isn't a lot because there's a lot more that we're going to do on here. Let's see. So again, they give you formulas. If you just understand the diameter is 2 times the radius, and remember, if we go in the opposite direction, if we want to go from the diameter down to the radius, we would divide by 2. So if you have the radius, you multiply it by 2. If you have the diameter, you divide by 2. So circumference, you get that. So I'm not going to spend a lot of time. You get this on the formula sheet per circle. You also get the area. I don't know if that's, they don't give you the area in here. Huh, it's weird. Yeah, they don't give you the area formula. You have the area formula though on the reference sheet. So with that in mind, are we on the edge? So go ahead, try to do example 1. Remember, do not just look at this in the picture. Don't look at what they did below that. They're doing it for you. Give you, I mean, that shouldn't take more than 2 minutes. So I'll give you 3. Go ahead and do example 2 also. And same thing, don't look at their solution. Just look at this. Do example 1 and example 3. All of check for change. No, I see you're taking notes, but yes, it's gonna be a little, some of this stuff I'd like you to, if you just try this. The, oh wait, oh, there we go, age. Oh, 15. Yeah, I guess that should be this one. That's triangle scales. What do you think? What do you think? Oh, it does, okay. In our book, it's. What about that? Yeah. After that, I believe. That, no. I think we're on 190. And we're doing, see if you can find an exam, is that what you have? Oh, oh, wait, no, I'm sorry, here's one. Let's see if it says example one. Oh. Yeah. Yeah. That's it. Something like the phone. That's it. That's it. Looks like they know. So here, oh, wait, I can see. This one I can get. That's the one. I can see the circle has the raised, bumps, like this one. All right, so on number one. Again, nothing super complex yet. How do we name a circle? Are you answering? I'll let you answer a question and I'll let you go. How do we name that circle? For example, one. So it'd be called just circle X. Say, or you can write the symbol for the circle and then the X. What's the next question? What is the radius? Want to answer that since you couple? There's a couple ways you could name it. Yeah, you could say XT is a radius. You could say XZ is a radius. You could say XU is a radius. There's really three radiuses in there. Give me a chord. Isaiah, wake up. Give me a chord, Isaiah. Endpoints on the circle. Line segment, endpoints on the circle. Give me a chord. Example one. I was gonna say, have to be two letters, remember for a line segment, two letters. So SR, RS, doesn't matter which one you start with. Al, give me another one. ZT, again, what is ZT also? Also the diameter. Diameter is always a chord by definition. It goes from one side to the other side. Kellen, do you see any other chords in there? RS, ZT. There's not, right? That's it. we can't say from V to U that it can't be diagonal like that. Oh, did we miss XB? I don't think I said XB when we were talking about radius. That's a radius also. Camila might have said that. What's that? Well, why? I don't believe Y is on the circle. Y is that point right there. So we can't use that for a chord because it's not on the circle. Is that what your question was? Or why did they point? There's something we'll learn later about points that are inside the circle. I don't think we use Y for, yeah, there's nothing in there with Y being used, so it wasn't one of the answers. And then we already named the diameter was CT. That's the only place they show the diameter. In example 2, again, pretty simple. That won't be something you're gonna see on one of my quizzes. Chloe, what's the radius? So we take the diameter. TU is the diameter. They tell us it's 14. We know, well, if we're going from diameter down to the radius is shorter. That must be when we divide by 2 then. If they gave us the radius and we wanted to go up to the longer line, the diameter, that would be when we would multiply by 2. Simple stuff so far. Go ahead, try to find the circumference. This could potentially be on the quiz. Actually, this could be your exit ticket too. It's at least you're using a formula as opposed to just dividing by 2 or multiplying by 2. So circumference, what does circumference mean? We didn't really go over that. So it is, I'll show you in a second. The circumference is the length, basically, I can do this, I guess, of that black line. So if I started on this one point here and I walked all the way around until I was back at that one point, that would be how far I walked. It's the length of the black line, the distance around. I can't think of any other way to say it. If there's another way that you think of it, that's fine. Just put it in your notes. As long as you understand, if I cut that, like this, we actually did this in middle school when we did some circles. We would cut something and make it just one long line. And if you just measure it, that's the circumference. There's a formula for it when it's in a circle that uses the radius, which is the formula you're using in that problem. You do get it on the reference sheet. Oh, is it the same exact formula? Could be. Sometimes they say it's 2 times the radius. Sometimes they just say it's and then times pi. And then sometimes they just say it's the diameter times pi. Did they give you both of those in the book? 2 times pi times the radius? Or did they just give you pi times the diameter? I don't really even see it. I mean, they gave you a formula in the. Oh wait, no, there it goes. You. Yeah, they give you both of them. Key concept at the bottom of the. So again, just remember if you just remember that the radius is half the diameter, diameter is twice the radius. I don't love you memorizing formulas as I said before. So just if you understand that, then all you need to know is it's you take the length of the diameter times pi. And then if they give you the radius, you just have to multiply that by 2 first to get the diameter. Then what did you get for that one? So everybody can check their answers. I'm not even gonna worry about it. I'm hoping everybody can do that one. Helen would get the one with the circumference. So the graphic circumference. Yeah. You can do it. Yeah, why don't you guys do that? If I can tell everybody's done. Do it, come on. like I said, take advantage of the first quiz. You don't want to be in a hole after the first two quizzes, because then it gets really difficult. Once we start getting into these things that you've never even heard of, which was parts and words and all that stuff. I'll say it again. So did anybody else get 113.1? All right, so it looks like it's 113.1. If you didn't do it, jot that in the notes. Like I said, I feel like I'm pretty accurate when I tell you that you're gonna have a hard quiz. You're going to get into some hard quizzes at the end of this quarter. Circles are not easy. Take advantage of this first one. Don't tune out. Don't try it. All right. Let's see. What's the next one? So we'll do. Actually, go ahead and do the check. Not too bad. Actually, do the check, and so you should have done example 3. If you didn't, you can do it now. Do the check for example 3, and then do example 4 and the check for example 4. Example 4 is a little trickier. The formula doesn't change. You're still using the same formula. It's just that they're giving you different information. You just have to solve it differently. I do that in your own, and that one we will do. So, Eve, probably your exit ticket will be from this section. I was gonna do it on the next section we do, but I think that the difficulty level is high enough with my circumference stuff. That I can probably do that. It's still not real difficult, so it should be an easy point for everybody, but it's not as easy as just finding the diameter. So yeah, 3 or 4 kind of is going to be your exit ticket. 6 minutes. We'll say. Yeah, we'll say 6 minutes. Did anybody not get one of these sheets? This was from our last quiz. If you didn't get it, practice for a retake. This. Oh, there was only one problem like that on the quiz, but I didn't really assign book pages for that one problem. I just printed that worksheet out. Work together. Well. Hmm. Gentlemen. Oh, you go to the gym every day once you're back. Morning. Uh-oh. Oh. Hmm. Hmm. There we go. All right. So we will do these since this will be your exit ticket. Well, I mean, one of them will be your exit ticket. Shouldn't be super difficult. No, on Thursday. Yeah, just I like to try to give it to you ahead and like let you know ahead of time instead of the day of. We'll probably do one for bell work, so it'll be part of your bell work on Thursday also for those people that weren't here today. Oh, wait, this way, this way. Next. Oh, okay, here we go. So we did that one. Where is the chat? Is it the automobiles one?
Yes.
All right, automobiles. All right, so again, they've already kind of solved it for you. We really should just be oh, actually, no, they haven't. They don't solve the check for you. All right, so we have to first of all read it. Word problems, circle numbers. There's a whole process. We haven't done tons of them, so we haven't used it as much. So we have radius of 7.5. So here's the way I do problems. If I know something immediately as soon as I read the problem, I don't care what, I haven't even gotten to a question, right? I literally just saw that number. What do I know if I know that the radius is 7.5 inches? I just go ahead and write then the diameter is 15. And I like using the variables. If you don't use variables, you can write the words out. So I know the radius is 7.5, diameter is 15. I just write everything I know immediately. Then when you come back, so first of all, sometimes that helps you because if you try to go straight to the question, you may not have something that you need to figure out anyway. But if you've already figured it out, then that might help you clarify what your steps are. Let's see. The width of the tire is 6 inches. This is going to be a tough one. So so this is definitely a picture kind of thing. What are they saying then is why are they giving us the width of the tire? Yeah, because it's not going to cover the whole. So the inner edge, so again, this is one that could sort of be up for interpretation. The way I interpreted this, and we'll just have to figure it out, and that's probably why it's multiple choice, because that way, if you interpret it differently, you'll see you get the wrong answer, and you can go back and change it. I believe they're saying that's 7.5 right there. Inner edge to the center, that inner circle. Okay, does anybody read that differently? And then you are subtract, but think about that. What would we be left over with? Did that. 7.5 subtract 6. Is that what you're saying? Subtract.
Oh, yeah.
Which that would leave us only 1.5, which is like that wouldn't really make sense. Now what would that mean I would be able to continue to do in my drawing from that 7.5? I could draw it all the way across. Here, let's do a different color. I could say, well, I know then if I had the diameter, that's 7.5. Which means, again, my diameter is 15, so I could draw that in. So now I have a diameter of 15 across the inner circle. What else can I draw in based on what they gave me? Jamarcus does on understanding. Like I said, there's a lot of reading comprehension in these. I'm just trying to draw a picture. Trying to draw a picture based on the word problem. Now, I've already put in the 7.5 inches. We said we believe the inner edge means, because you know how you have a big tire and then there's a big circle on the outside, a little circle on the inside of the tire. So we believe the inner edge means the radius is that 7.5 in on the little inside of the tire. So where would we put the 6? On the other. Or my assumption would be that we just continue from the 7.5 out to the edge, and that would be 6. If I wanted to do that on the other end and find like what is the radius of the big tire, I could do that. So again, the diameter of the inner circle, the small circle inside the tire, would be 15. the diameter of the whole tire, like the outer edge of the tire, would be 15 plus 12, so 27. And then I've got each piece if I really need the individual. Oh, so the radius. So what's the radius of the big tire, like the outside edge of the tire? Okay, you add them together, right? So 13.5. So I've got the radius. So I think I've got everything I need now set up. Now I go and see what they actually ask. So it says find the circumference. So if you weren't able to set it up, I want you to try to do the circumference from that drawing. Hello. Can I zoom? I don't think I can zoom in anymore. I think, yeah, I'm on 300, so here. And yeah, let me do this. Boy, this is where it gets tricky to highlight stuff. Yeah, because this is all individually. How can I do this? You guys keep working. I'm going to try to make it larger. And go there. All right, that should work. There we go. All right, now we can use that. So I've already identified something. Oh, actually, I probably need to label these. So that would be the inner circle of the tire. So the outer circle, we said, well, that would be the diameter would be all of those added up. And the radius would be half of that. All right, who am I going to call? Israel. Haven't made no Israel yet. So again, this part is kind of reading comprehension. What does it mean when it says, what's the circumference of the rim? And you kind of got to know what a rim is. What are we talking about when we're trying to find the circumference of the rim? Which circle would we be focusing on? If the rim's actually going to be in, because the rim doesn't cover, like you can still see, the black of the tire. Sometimes the rims are really big, but normal rims just cover really that inside circle. So it'd be this inner circle here, I guess it's green. So that, again, my interpretation of it is that would be the circle I use for the rim. So now if that's the circle, I can go ahead and say, all right, well, what is which I really don't even use. So the 6 that they gave me in this case, I don't even use. Like if I'm just trying to find the circumference of that, I would just use the 7.5. What's the formula? Rihanna, sit your back. What's the formula for circumference? In your pages, yep. At the bottom, I think, is 189, maybe. Is that where it is? Anybody on 189 or anybody 189? So what's the formula for circumference? Height times diameter, which we did go ahead and figure out. So even though they gave us the radius, we went ahead and figured out in the beginning. If you didn't figure it out in the beginning, now would be when you'd have to recognize you need to do that. Or you could just use, if you remember it, and I think this is on your reference sheet. I think they give you both formulas where it's 2 pi r. So you could just use the formula with the radius in it instead. You'll notice, do not multiply pi out. They just leave pi in the answer. So sometimes the EOC is going to do that. The district step will do that. Sometimes they'll want you to hit the pi button and actually multiply it all the way out to a decimal. Sometimes they'll just leave pi in the answer. Like there, it's there, it's there, it's there. So you got to know how to do both. All that means is you just don't push the pi button. You just multiply, in this case, 2 times the radius. You get 15. So it's just 15 times pi would be my guess. So C would have been the answer. I have no way of knowing for sure that that's correct, but it's in the options, so I'm feeling like we're probably in pretty good shape. If you interpret it differently, one of these might still be an option. I don't know. But I can't think of another way really that we could, unless you somehow thought they were talking about the whole outside. But if that's the case, it would be 27 pi, which, oh, that is an answer. So again, your reading comprehension might be the difference in getting this one right or wrong, and understanding what a tire is and what a rim is and all that kind of stuff. I don't put word problems like that just for that very reason. I'm not sure if that's for myself, but the district does. What would you say the assumptions were that we made? Assume the radius. Did I assume the radius of the tire rim? No. Not really. Now I assumed that the rim only covered the inner circle. Like I assumed we don't have a rim that covers the whole tire. I did assume that, but I didn't really assume that I didn't assume what the radius was. They gave me what the radius was. Let's see, I assumed that the tire rim was a perfect circle. Yeah, I did assume that. And I can't use the formula because I don't have a perfect circle. I assumed the width of the tire. Did I assume that? I didn't assume it. I didn't even use it. Like, I didn't use the 6 at all. We were supposed to. We didn't. So that's why maybe they just gave us extra information. Maybe we interpreted it wrong. We won't really. I could look it up in the teacher's guide, but I'm not worried about it. I assumed there was no space between the tire and the rim. Did I assume that? Did, right? I didn't add any space in between this 7.5 and 6. So that's what they mean by that assumption. I assume that that rim went all the way to the edge of the tire, and then the tire itself went out to the outside of the tire. I did assume there was no space, and I assume the tire and rim were not the same shape. I didn't assume that at all. I assumed they were the same shape, right? I assumed they were circles, even though I didn't really use the outer circle. All right, so then 4, find the diameter and radius of a circle. So this one is, if I'm leaning toward an exit ticket, this is the one that I'm leaning toward, because it's a little more complex. Still same formula. You have it on the reference sheet, so there's nothing you have to memorize, but you do have to do a little more complex. Actually, and if I use this one, I could probably make it 2 points again. Set it up correctly. There's 1 point, and then solve it. There's 1 point. So, what's my formula again? It's about what? About circumference. So, what's my formula for circumference? So, where am I going to do this? Blue. Let's do it down here. So circumference equals, I'm going to write 2 pi r. I normally use the one with the radius in it. I can always multiply times 2. Now I have to find both the diameter and the radius. So I'm going to find them both. So you could use both formulas if you want, or I can just find the radius and then convert that into diameter. Well, what's the difference in this one? What am I doing here? Yeah, I'm not using the diameter to find, or the radius to find the circumference. I'm going the other direction. So what am I going to plug in for my equation? Chloe. Oh, wait, Let's rhyme with Zoe. Let's go with Zoe on this. What am I gonna plug in? We're doing example 4. I've already found my equation on the reference sheet. And they want me to find the diameter and the radius. So what am I gonna plug into that formula? Basically the only thing I gave you. Example 4. Well, they solved it. Don't look at that. They're solving. You're only looking at the bold up above. That's all you do. So what do they give me that I would use in the bold text?
77.8.
Which is the circumference. So I'm just going backwards. Instead of plugging in r and solving for circumference, instead of plugging in radius and solving for circumference, I have the circumference. So I'm plugging that in and saying that equals 2 times pi times r, which I can solve. I can still solve that, like as long as I only have one variable in an equation. So that would be your 1 point. Now, how do we solve that? How do I solve for r in that? Shot A. How do I solve for r in that equation? Wait till see a little better since I'm writing over the top of words. I have this from. Wrote it in already. I already filled the equation out. How do I solve it? There we go. I get r by itself, right? I'm going to need to divide by both, right? If I have r here, so this is the same thing here. I'll just make a thicker line and it'll show up over the top of everything. So if I have 2 times pi times r, so all 3 of those things are being multiplied. The way I get r by itself is to do the opposite math. So if you want to do it in steps, which is what I'm going to do, that's fine. First, I could say, well, let me divide by 2. That gets rid of the 2, it divides out and just becomes 1, which just kind of goes away. So then I need to divide that by 2. So that 38.9. Wait, no, you got that's the final one. So you're doing the final one. Are you? Because yeah, so 2 goes into that 3, right? And then it goes into that 8. Yeah. So 38.9 first. So 38.9 equals pi. I still have the pi left. I didn't get rid of that yet. I only got rid of the 2. So now, well, again, if I'm trying to get r by itself, and if that's multiplication, I need to do the opposite. Divide by pi. That means pi divides out into 1, which just kind of goes away. I'm just left with r. Well, I divide by pi over there. I gotta divide by pi over there. So now somebody do that for me. And you can just use the pi button. What was it again? 12.38? R, we're gonna write that down here.
Are they allowed to use 3.14?
It'll tell them typically to use 3.14 or to use the pi button. The district likes you to use the pi button, so practice that. Just means when you hit divided by, you just hit. Where's the pi button at? Yeah, it's not even a second function, it's just right there. So you would just hit 38.9 divided by, and then hit that button with the pi symbol on it. It's actually faster anyway. It's more accurate and it's faster. You don't have to type in 3.14. So just get used to using the pi button, unless it says in the problem use 3.14, which typically the district says use the pi button. Or they don't say anything at all, but they want you to use the pi button. So try to do, if you haven't done the check problem, I'll give you a minute to do that, and then that'll be the last thing we do. You've already done it, you can, oh, I'll, for those of you that have already done it, I'll give you some practice problems. Oh. Yeah, we're pretty much on. So practice problems, we're gonna wind up doing more than this, but I'll just assign is that 1 through 15 on zoom in too much. So 1 through 15 on page 193. Like I said, we'll add more of that.
I remember playing jokes on the pizza places. If you call up and ask, hey, what's the diameter of your large pizza? Which like, if it's like an 18-inch pizza, that means it's the diameter from one end to the other. But if you ask them, what's the radius of your pizza? They don't have a clue. So if it's a 20-inch diameter, what would the radius be? Yes, they don't know that. Okay. So most people think an 18-inch pizza is the circumference. It's not, it's the diameter. It's a little joke we used to play on that in college.
What would we call this? This we'll just call this radius.
It's been here today.
No, he's only been here one day. He showed
I
up.
called them.
Showed up yesterday. Yeah, he showed up yesterday. He goes, yeah, I just got transferred over. So he showed me the schedule. I looked at it. It said February 24th.
Yeah. I told that, she's not been found out.
Yeah, I don't really understand that. You know, we definitely have to do those other examples though, because that's on their quiz. I know for a fact. I'm not gonna, I could have gotten through that today, but oh well. Oh well. What you need, girl? Paper? Yeah, there may not be printed, but we. Yeah, I really should have. I'm gonna go ahead and assign example 5 to you as well. So we just did 4. All the examples are fair game for the quiz too. So examples 1 through 5 are fair game for the quiz. This one, I'll tell you right now, example 5 is on the quiz. Like, I remember that picture. So something like that is on the quiz. So we'll go over it, but I want you to try to do it on your own. Not today, but we'll again quickly go over it. So you need to put some effort into it yourself. But I'm gonna go over it super fast, basically just so you can check your words or answer any question, right? It's not gonna be a full lesson. We're done with this lesson. Going in. I mean, it's the only tricky part is just reading the figure, but it's still just line segments and radius and. Mhm. Oh. Yeah, sure there is. There is a diameter. You may not like have letters on the other side. But what would the diameter be? What's the definition of diameter? Every circle has a diameter. They may not have drawn it in. So, but what is the diameter? If you need, like, I'm assuming they're giving you numbers. Yeah, so what is the diameter? May not be drawn in, but what did we say the formula for diameter? Equation formula. It's because they don't draw it in, doesn't mean it doesn't have a diameter, it just means you gotta figure out that. Or I guess they do give you the diameter, so you're going the other way for the diameter. They give you the diameter for circle K. You're doing 5, right? They tell you what the diameter of circle K is. Yeah. So what are you going to use out of that part? Because they don't even have it drawn in, like you said, so you probably don't have to use them. Right. So what is the radius of the post? Like what point? No, but what lines? DK. So D from D to K is 6. Well, I don't even know what the question is. I just figured that one part out, but that's how I solve the problem. I go, okay, well, if I know, I'm doing it for you, but if I know the diameter of K is, well, there's really nowhere to write it in because they don't have it drawn in, like you said. So the diameter of K is 12, then I know DK is half of that. So DK is 6. I don't even read the question until I filled in some information first. And then I would say, what else is it? The diameter of J is 20. So I know JE is 10, half that, right? I don't have a point over here, so odds are I'm probably not going to use the diameter, or they would have probably put a point there. So I'm not even going to write it in. But I know those two are the radius right there. Of those two. And again, reading the circle is a little tricky. Yeah, I kind of remember this problem. Oh, wait, it does tell me that JD, so I would kind of draw this in myself in the circle. Is that 8? So JD is 8. And now you should be able to figure out, I mean, they've done, that one's done for you, but you need to try to do the check problem on your own. Assuming there's not a check problem. Yeah, make sure you can do example 5 on your own. They did the whole thing for you, and I know you guys tend to just kind of go straight to their solution, but I'm telling you, that's on the quiz. You can't do that on your own, be in trouble. Reading the figures probably becomes part of it. I think there is probably an example on the next page. What's that? Yeah, so it's just the whole JE we know is 10. That's 8, so DE is 2. I guess they don't tell you the answer anymore. So they give you the steps, but you do have to do the math. So yeah, it should be 2. So let's see. I think there was an example. Yeah. So there you go. So oh yeah, just remember the examples always have matching problems in the practice, so you can do those for like that one. It's like I said, I know for a fact there's one like that one. Did it ask for anything? Well, you got all the other ones, right? And you got 3 segments. Tell me. So we just saw it and we said that, right? You told me DE was D2, right? So if I know that's 2, you should be able to figure out EK. K is the center of the smaller circle. Or what? That's correct, because DK is 6, right? We just saw we came up with 2 there. So that would be good. Again, the only hard part, or not even, I mean, I wouldn't think it's too difficult. Well, I told you, take advantage of the first quiz, because it gets way tougher after the first quiz. Way tougher. Why do I do it? Because I'm not just gonna tell you answers. Because I'm not just gonna tell you answers. Because I want you to figure it out. But I don't want you to ask me at all. I want you to figure it out. Yeah, you know what? Teaching doesn't mean telling. Big difference. It means helping you figure it out. It means helping you figure it out. It means helping you figure it out. And making sure you don't use your phone, you don't leave my book. So I didn't do so well in studying. Yeah, if your teachers just tell you what to do, it doesn't stick. That's a psychological learning fact. Well, if you put the effort in and try to figure it out, it would stay. You struggling with something and figuring it out lasts way longer. Stick with this. Back over there. Copying, like proven, copying doesn't help. People just telling you steps doesn't help. You figuring something out for yourself is what helps you retain. So I'm supposed to help you figure stuff out. Oh, the one you missed yesterday? Yeah. So come when? Well, you can come either one. I don't care which, if you're doing it one, I just didn't want you to come after. Although actually I could do after. Or like I have to leave at probably 2:40. Either one, lunch or either one. If you can do lunch, just, you need to get here like fast, because it's probably longer than a 30-minute test. So get here as soon as you can, and then if you need to stay a few minutes, I'll kind of let your teacher know that you're taking a quiz, and then you might be there a couple minutes late, so I'll give you about 35 minutes. Yes. Well, yeah, you've gotta have some problems, like right angle, 20 to. You need some problems that you try. Problems you try. Well, you should be doing the ones in the book.
Yeah, that's the same thing, but that's like. What is the book you have?
You're on the wrong chapter, girl. I told you that, that's right. It's wrong chapter. Then it doesn't have 2 numbers filled in unless you're solving for the angle. They might, some of them you're solving for an angle and then they give you 2 sides, but if you're solving for a side in that chapter about trigonometry, either they give you 1 side and the angle, or they give you 2 sides, but then you have to solve for the angle. That's the way every problem in that chapter works. Oh, I can stop the recording. Oh, so again, I'll add more problems tomorrow, but I wrote it up here, page 193, 9 through 15 is what you're responsible for as of right now. It's mostly for the recording. Because all of you obviously already wrote it down since I told you to write it down. Exactly. Exactly. It's up on that board over there too in red. I got to go back. Oh, I added some IXLs already for this stuff. You don't go in and check IXLs. I add them. Like I don't, whoa. Al got confused. So he was in somebody else's classroom. Yeah. So yeah, I add IXLs in all the time. I don't make them a big deal because I don't think they're hard enough. I think they're too easy. But if you're really, really struggling with something, go into IXL. And I will tell you right now, circles is a good one because you're gonna really struggle with some of the stuff in circles. It's just a lot. So that would be a good one to just get a lot of repetition on, whoops, ah.
I got